Hello, linear algebra student. This video is for chapter 1.8, part 1, Introduction to Linear Transformation. Linear transformation is a very important concept in linear algebra. What is a transformation? So maybe you have learned about transformation when you do graphing, like how you move the graph left and right and up and down, all those, but this is different. Okay, linear transformation is analogous to a function. So in the past, when you learn like algebra or pre-calculus, you have learned that you can, you know, associate, like if you have f of x equal to 2x plus 1, so this is a function. So then if you have f of 1, that means you plug in 1 and it's equal to 3, right? 2 times 1 plus 3, meaning you still remember those mapping diagram. You have like domain x and this is y, 1 map to 3, okay, plus 1 equal to 3, right? So 1 map to 3, so this is called a function. So linear transformation, or actually before we talk about linear transformation, is another term for function, but the input is not one number, the input is a vector. Okay, a vector like x1, x2, x3, vertical vector, like a column vector. So let's read what is a transformation. A transformation or a mapping or function is a rule from not a number r, but r to the power n. So that means you plug in not just one number x, you're plugging in x1, x2, all the way to xn, so the column vector, to a function, and then your answer is not the same Rn, but another one is b1 all the way to bm. So it could be a smaller vector, it could be a larger vector. So this rule is the rule you specify. And then you can, so one way to do it is you can use a matrix to transform it, meaning how do you get the B? How do you get the like this is the domain, right? It's basically just like function. And this is range. To get from X to this B is you use matrix multiplication. Okay, you multiply this in front, okay? Use a multiply to it and it become this. So we call this is a matrix. This is a transformation. And if you are using matrix to do the transformation, it's called a matrix transformation or a linear transformation. And we'll talk about those later. But in general, a transformation is just a rule that map one vertical a vector to another one. So if your matrix, so if you're doing matrix, using matrix to do transformation, then matrix can be, you have to have, and if your input is a, 4-entry one, then you need to have 4 column vector, right? So you can have any row that you want, but you would have all the 4 column vectors. So this 2 has to match. And then the result will be B in R2 because you have 2 row, right? You have 2 rows, so it become you combine them together and you become a vector that is the same as the number of row. Okay, so the input x matches with the number of columns in the matrix, and the answer matches with the number of rows in the matrix. So basically, the notation that you do would be you say t x go to a of x, and this is a transformation. It's a matrix transformation. So for example, I can define my matrix as 1, 1, 2, 3, 1, 0, 4, 5, and I multiply to x1, x2, x3, x4. Do you still remember matrix multiplication? This means this vector, so remember this is x1, this is the weight, right? Times 1, 1 plus x2. So this is the ways to do the linear combination of those column vector 2, 3. But this weight itself become an input. And then after you add x3 and then 1, 0 and 4, 4, 5, you get to equal to B1, B2. Okay, so this is called a matrix transformation because you're using matrix. And remember, the matrix has to be in front of your input matrix. But a transformation can just be a rule, right? So this is a matrix transformation, but in this example, I am not using matrix. I would just have a matrix and I map it to the 2 by 2, a column vector of 2 by saying, just add these two together, x1 plus x2, then just add these two together for the second one. This is also a transformation. It's just a rule. Anytime I input something, I have an output. But this would not involve matrix, right? You see that you do not need to multiply anything. It's just like that. So there could be a lot of transformation that you can do to deal with a column vector to another column vector. So what is the notation of a transformation? So the way we do it, if it is a matrix transformation that involves A times X, we're not talking about these. We'll talk about these that's non-matrix one later, and especially in 1.9. The next section we'll talk about more of these, but for the time being, all of our transformation is a matrix transformation. So our input is X, and then we multiply X in the front by A. So you have to specify what to what. Okay, so Rn is the number of columns in A, and M is the number of rows, number of columns in the answer in B. And then you write, so this is kind of like the most common writing. So first you define the name of a transformation dot dot and then what to what, and then you say T of X equal to AX. When we talk about function, we always have domain, right? So this is the same here in transformation. So what's the domain? The domains are all those vertical column vectors. So in Rn, so we call the domain. Rn is the domain of T. You can input anything you want. T of X, where you input in, this would be Rm. So it might not be all of the Rm. We say T of X is the image of X. So if you map X to a T of X, so we call this the image, right? Like the output. What about the range? So if you have all the Rn, a lot of them here, and you map to different one, so that it may be all of Rm, but it could be just a small subset. So the range of T is the set of all linear combination of the columns of A. So if you can combine all of the A, then you would have all the images together is called a range. The range are all the images from all of Rn. A matrix transformation, you can also write it as X to A of X. Starting with the input, go to the output A of X. So let's do some practice. Example 1, I define A equal to this, and then I define a transformation is R2 to R3 by T of X equal to AX. So using this as the beginning, and then I have U equal to 2, negative 1, B equal to the 3 vector. So find the image of T of U. So that means U image of means what is it after the transformations of U is the input. So I write T of U would equal to A times U, right? T of X equal to A times X. So it would be A 1, 1, negative 1, 2, 3, 7 times U. Remember 2, negative 1. If we are multiplying a matrix with a column vector, we can do row times column. So that would equal to 1 times 2 plus 2 times negative 1. And so negative 1 times 2 plus 7 times negative 1. Right? Or you can think of it as 2 times this column plus negative 1 times this column. Oh, there is another one. I skipped the 7. So we 1 times 2 times 2 plus 3 times negative 1 also, right? I missed the middle one. So there's 3 of them. So each one multiply this, each one multiply this, each one multiply this. Or you can say there's two ways, right? Still remember it's 2 multiplied with the first column vector 1, 1, -1 plus -1 multiplied by 2, 3, 7. Both of them will give the same answer. You can use the matrix multiplication, or you can use vector combination, vector equation. So all of these would means 1 times 2 plus 2 times -1, that is 0, right? And then 1 plus -3 is -1. -1 plus -7 is -9. And you would have the same here. So -2 plus -7 is -9. 2 plus -3 is -1, and the first one is 0, right? So this is the answer. So this is called the image of U. U is 2, -1. The image of U. There's a lot of these terms you just need to know. It's a bigger matrix, -1, -9. Because this is a R2 to R3. You start off with a U matrix, which is R2, and your output is an R3. So M and N can be anything. It doesn't have to be M is greater or M is larger. B, find X in R2. His image is B. So I want to do the other way around. If I know the image is B, what is X? So that means AX is equal to B. B is -3, -4, -6. So solve for X, right? So this is the same as what we have done in like 1.1, right? So this is solving an equation. How do I solve it? I use an augmented matrix. Still remember? It's like very basic. So 1, 1, -1, 2, 3, 7. Then the augmented is -3, -4, -6, right? And then we do reduce row echelon form using our calculator. 1, 1, -1, 2, 3, 7. Is it 2, 3, 7? Yeah, 2, 3, 7, -3, -4, -6. -3, -4, -6. Remember, the last one is the constant column. So, and then I do a reduced row echelon form. I have 1, 0, -1, 0, 1, -1, 2, -1. Okay, so it become 1, 0, -1, 0, 1, -1, and then 0, 0, 0. So I have solution, right? Because I don't have any 0, 0, b. And x1 is equal to -1. x2 is also equal to -1. So the x is -1, -1. So when I start off with -1, -1, my image is -3, -4, -6. C, determine if B3, 1 is in the range of T. Now this is very interesting. The range of T should be a R3, right? CR3. So range means the output side. So this cannot, right? Cannot. Because the range is in R3. So this is a R2 matrix. You can never be. Cannot happen. So D, determine if C equal to 3, 0, 1. Now we have R3. Is it in the range? So they ask this one, this doesn't make sense. This one does make sense because it's R3. So can some X solve to this? So that means AX is equal to C 3, 0, 1. Is it possible that this is in the range? That means can I find X there? So let's again solve for using augmented matrix, right? Augmented matrix to do 1, 1, -1, 2, 3, 7, and then the constant sign 3, 0, 1, right? So do a reduced row echelon form. So whatever that you learn in 1, 1, 1, 2, that's what you're gonna do now. 3, 0, 1. So change this side to 3, 0, 1. Okay. 3, 0